Hey Precal. Alright guys, we're going to do a recap. Alright, we're going to do identities. Okay, we're going to recap from the very beginning when we started to all the way up until the sum and differences of sine and cosine. So, you all know these, tangent of A is equal to sine A over cosine A. Y'all know those. Y'all got this. Don't worry about it. Alright, so let's just do a recap, okay? Simplify. Okay, guys, on your recap sheet, okay, I gave you some notes, okay, in case you lost them, alright? But 1 through 6, use your identity sheet right here, okay? You got this, alright? But I do want to go over just a few to help you understand how to do the rest on 7 through 14, okay? Number 7 and number 11, let's just talk about those, alright? Sometimes you can get your answer, you can simplify, alright, by just getting everything in terms of sine and cosine. So this is what I'm going to do, alright? Well, this is already in terms of cosine, right? Cosine is cosine. But tangent can be written right here as, using our identity sheet, sine over cosine. And since we're multiplying, these two guys actually cancel out. And what are you left with? Sine of theta. Bam. That's your answer, okay? Your goal is to always get, okay, everything in the numerator, nothing in the denominator. Well, let's look here. I said sometimes it's best to get everything in terms of sine and cosine. Well, sometimes you might have to think outside the box a little bit. Let's look here. Secant squared of theta minus 1. Well, let me look. Okay, I'm looking at the identity sheet. All right. I'll look at number 9, okay? I see secant squared of alpha, okay? And tangent, if that's equal to tangent squared of alpha plus 1. Now, some people might do a little rearranging of this identity to get an answer more quickly. Right? But I'm going to do it the way that you would do it if you were just looking at your identity sheet and applying it. Okay? So this guy right here, we said we have an identity. Alright? We said this is equal to, according to our identity sheet, tangent squared of theta plus 1. And don't forget the minus 1. I gotta bring that back down. Well, what happens here? What cancels? The 1s, right? And you're left with tangent squared of theta. All we're doing is simplifying right here, 7 through 14. You got this, okay? Alright guys, now we're on to proofs, alright? So I'm going to do number 15 with you guys, okay? Looking at this, right, we always say we're going to get the left hand to look like the right hand side. We're proving that this right here is equal to secant of x. So we're not going to mess with the right hand side, we're going to mess with the left hand side. Alright? So I say because we have secant's like 1 over cosine, maybe we should get everything in terms of sine and cosine on the left hand side. Alright? Case in point here, tangent of x and cosecant of x. Let's see what happens, alright? So I'm going to change the tangent, okay? I'm going to change the tangent to sine over cosine. Sine of x over cosine of x. Alright? Now this is going to be kind of weird, but this is the way I'm going to do it. Cosecant, alright, still have this major division sign happening here. Cosecant is 1 over sine. Now this looks really weird, a fraction divided by a fraction. We're going to fix that in just a sec. But you still have the plus cosine of x, which is equal to secant of x. Well, we know when you divide a fraction by another fraction, if you divide by a fraction, you multiply by the reciprocal, and that's exactly what we're about to do. I'm going to rearrange this. I'm going to say sine of x over cosine of x times the reciprocal of 1 over sine of x, which is the sine of x, plus cosine of x is equal to secant of x. This is like saying over 1. So when you multiply fractions, you multiply the numerators and you multiply the denominators. Don't multiply this to both of them, right? We'll just multiply it to the top. Here we go. So you get sine squared of x over cosine of x plus cosine of x, which should equal secant of x. We're going to get there, right? Think about this. Well, we said this is like, here you have a fraction, here you have a whole number. This has a denominator of 1, this has a denominator of cosine. We need to combine them to a single expression. Here there's 2 terms, we need to get to a single term. Alright? So we need to find a common denominator in order to do that. We're going to multiply top and bottom by cosine of x. So now that are both denominators will have a cosine. So you'll have sine squared of x plus cosine times cosine. Cosine squared of x over the common denominator of cosine of x, which is equal to secant. Well, right here, that is an identity. Identity number 8, I believe. I'm wrong. It's 6. Number 6. Okay? Sine squared of x plus cosine squared of x, that's equal to 1. So all of this right here goes to, that's an arrow, to 1. So we get 1 over cosine is equal to secant of x. Well, 1 over cosine is secant, right? We just proved it. Secant of x is equal to secant of x. We just proved that this stuff, if we do a little rearranging within our identities, we'll get secant of x is equal to secant of x. We just proved it. Alright? So I'm pretty sure you can do number 16 very similar. Alright? Okay guys, look at number 17. Okay, 17, 18, you're going to condense using the sum and difference of sine and cosine. 19 and 20, you're going to expand, okay? But think about what's A and what's B. This is what I'm getting at here, okay? If you look at number 17, sine of 70, cosine of 10, minus cosine of 70, sine of 10, that kind of looks like this right here. If I just make the 70 and 10 an A and a B, that looks like number identity 16. This is equal to sine of A minus B. So let's just do that here. This is sine of 70 minus 10, which is equal to sine of 60 degrees. But we can't stop there. We know what sine of 60 degrees is. If you look on your unit circle, it's square root of 3 over 2. And there you have it. If you can solve it, you can. If you can't, you stop. There you go. Hey guys. Oh no, look. New clothes. Actually, I just ran out of storage on last time, so I had to wait another day. And so that's why I'm in different clothes. Not that y'all probably even watch this video to notice. Anywho, okay, so we're going to do number 20. Now number 20 is using the same identities the same kind of variety of identities. 14, 15, 16, and 17, those are the ones you need to look at. But instead of condensing in this situation, we're going to have to expand. Number 19 is like number 20, but you have to expand two identities. Here we're only going to expand one. I said I want you to expand and then reduce if you can by evaluating. Stuff might cancel, but you're going to end up getting a single term in the end. Right? So here we go. Cosine. Well, to be honest, I'm going to rewrite these as x in blue and pi in red. Reason being is because I want us to look at it in this way. Cosine of A minus B. This is identity number 14. Okay? So let's expand this guy out and we'll see how it's very similar to this guy, just got stuff in place of A and B. How would I expand this? Looking at my identity on number 14 said this is just simply cosine of A, cosine of B, it's opposite with cosine, plus sine of A, sine of B. Of course, you know me, I like to put my colors here. That's the identity that I'm going to use. This is number 14 on your identity sheet that I gave y'all, okay? So if you lost yours, you have it in a gold sheet. Awesome. All right, so let's expand this out. This is going to be cosine of x times cosine of pi. Yeah. Plus, because it's opposite, because cosine identity for the difference in sums of cosine are opposite when you actually expand it out. Cosines tend to do that. They always do opposite of what you think. This is going to be pi, this is going to be pi. Kind of going out of order, and this is going to be x and x. So I said evaluate what you know. Okay? So we're using this to help us figure this out, right? So let's just look at here on top. Well, cosine of x, I don't know what it is. Cosine of x is just cosine of x. But cosine of pi, pretty sure. I'm going to circle it. It's kind of hard to see, I apologize. But I'm going to make it, not really crossing it out, but make it kind of go to an arrow. Kind of a better color. Will this be brighter? Ooh, brighter. And we're going to say this is equal to 1. Because, more specifically, negative 1. Plus sine of x, which is the sine of x, but then sine of pi. Looking at your identity sheet, which is where I got that from, sine of pi is, that goes to 0. Okay? So I'm going to just rewrite this just for the sake of it, you know. This guy is equal to cosine of x times negative 1 plus sine of x times 0. Well, anything times 0 cancels. That goes away. So what's negative 1 times cosine of x? Negative cosine of x. That is your answer. That is what this is equal to. Okay? This stuff here in the middle was just a little helpful guide. Looking at our identity sheet. Alright? By using our identity sheet, we were able to find these. Okay? We expanded it out, evaluated what we could. Some stuff canceled, some stuff was evaluated, but we then just multiplied it to the cosine of x, and there we go, negative cosine of x. Alright, so work on those. Use 14, 15, 16, and 17 identities on numbers 17, 18, 19, 20. They're good. Alright, now let's go to a little more involved stuff. Alright, solving. So let's look at this one. On number 22, this is for find all solutions for x when x is between 0 and 2 pi. If you notice though, the inequality sign here is only with the 0. The equal sign, the inequality is with the 0, not with the 2 pi. So we're not doubling up our answers here. Alright? It's kind of hard to see, but it says cosine squared of x is equal to cosine of x. Looks a little daunting, you're kind of confused, what am I supposed to do? Now if I asked you this though, okay, hopefully you can see this. Kind of write it right here, very small, down low. This is kind of like this is analogous or similar to, what if we had a squared is equal to a? Some of us be like, oh, no, still don't know. Alright, it's a quadratic. If it's a quadratic, you set it equal to 0. In other words, I'm going to move this a to the other side by subtraction. A squared, therefore, minus a is equal to 0. Now it might be a little bit obvious. They have a common factor of a, which I could factor out, which is a times a minus 1, which is equal to 0. And then what I would do is set each factor, this factor, and then this factor, equal to 0. Solve for a, bam, done. Let's do that over here now, okay? So this was just a hopeful little guide, right? A little something you think in the side of your head. Or write it down, shoot a paper, I don't know. So what did I do? I have this situation going on here. I have a cosine squared of x is equal to cosine, just like this. So I'm going to move it over to the other side and set it equal to 0 because it's kind of like a quadratic. I'm going to get cosine squared of x minus cosine of x is equal to 0. What did I do after that? I found a common factor, in this case a common factor of cosine. Alright? So cosine of x times, pull out or factor out a cosine, I'm left with cosine of x minus 1 is equal to 0. Now I have two factors equal to 0. Guys, this only works if it's equal to 0. Remember that. So I'm going to have cosine of x is equal to 0. And then I'm going to have cosine of x minus 1 is equal to 0. Alright? Let me do a little more work right here because this one already got cosine by itself. I don't have cosine by itself now. Alright? I can add 1 to both sides. So when I add 1, I get cosine of x is equal to a positive 1. And now we rely on our unit circle. Where in a unit circle is cosine of x equal to 0? And where's cosine of x equal to 1? Just look at your unit circle. If you look carefully, you'll notice this happens in 2 spots. This happens at pi over 2 and 3 pi over 2. And then cosine of x equal to 1. Now, I said between 0 and 2 pi, but we don't want to repeat our answer because technically this does happen at 0 and at 2 pi. But because that inequality sign right there, when it says to find our solution, it only wants one of them, just 0. So x is equal to 0. That's where that happens. You know me, I don't like to go look for answers. So if you could please, just stick them all together in one area. Hopefully in order if you can, if not, no big deal. 0, pi over 2, and 3 pi over 2 is what x can equal in order to make this statement true. Now guys, I can't harp on this enough. These answers need to be plugged back into the original equation. If you have something funky like a reciprocal function or a tangent, then plugging back these in is essential because sometimes you might have an indeterminate on one of those answers, meaning yes, you get an answer, but it's not a solution. Well, since our answers are here and we're dealing with just strictly cosine at the beginning of our equation, we don't even really need to check. We just know these are right because these aren't going to screw anything up here. If you plug in something for tangent though, like say tangent was up here and you have 3 pi over 2 or pi over 2, you know good and well tangent of pi over 2 and 3 pi over 2 is undefined. We couldn't use those answers as solutions. Be careful with that. Always plug them back in. Plug them back in, plug them back in. Alright? Now, give you a heads up, number 20, kind of like 22 in a sense that you have to factor, but my hint is factor. I'm going to be more specific. You probably need to box that sucker, okay? Think of it as a 2a squared plus a minus 1 is equal to 0. It's already equal to 0, but you got to factor using box. Number 21, I'm going to let you kind of think about that. Use an identity, multiply stuff over, set it equal to 0. If you have questions, you know where to find me. But number 21 is a good one. All right? It looks simple, but it takes a little thought. All right. Okay, last one I'm going to do. Let's look at 23. I'm going to do the cosine of alpha plus beta, or a plus b, whatever you want to say. I'm going to write them as alpha and beta. I might say a and b. Y'all probably like that anyway. Okay, so they give us some parameters though. They say sine of alpha is equal to 3 over 5, while sine of beta is equal to 24 over 25. Knowing that alpha is between 0 and 2 pi, or sorry, pi over 2, and beta is equal to pi over 2 and pi, I want to know what cosine of alpha plus beta is. Well guys, that's an identity right there off the bat. Alright, you know what I'm going to do? I'm going to expand this right now. I'm going to expand this, and then once I find that I am stuck and I can't go any further, I'm going to go back and review what I was just given, what I just said, and I'm going to fill in those gaps that I don't know. Alright, so let's use our identity. This is identity, I believe number 15. Cosine of alpha plus beta. Cosine of alpha plus beta is actually equal to, we're going to figure out what this is, the numeric value given all this information. Alright? It's going to be cosine of alpha times cosine of beta, but since it's plus, this is minus when you expand. Sine of alpha times sine of beta. Okay, well let's look and see what we do know. We know for a fact that sine of alpha is actually equal to 3 over 5. Not alpha, sine of alpha is 3 over 5. We know that sine of beta is equal to 24 over 25. Alright, there's still this minus sign here. We still have cosine of alpha, and we still have cosine of beta. This is where we're stuck. I do not know what these are, what values cosine of alpha is. I don't know the numeric value of cosine of beta. But that's why they give us this information up top. Let's look back here. What does this mean when we say alpha is between 0 and pi over 2? What quadrant are we in? We need to be very specific and understand that. This right here is just quadrant 1. What about beta? That's quadrant 2. Alright? So what I'm going to do is I'm going to draw basically triangles, because we know that sine, both, no matter what, is equal to y over r. This is y over r. We can make triangles in terms of x, y, and r. Alright? And where I can do that, I believe I can fit it over here. I think you'll be able to see. I'm going to make, because they're in different quadrants, I'll just draw it right here. Let's do alpha first. That is in the first quadrant. Alright, the y value and the r value. R is 5, The y value is 3. So this is y, this is r. We shouldn't be too surprised to know that the x value is equal to 4 when alpha is right there. Okay? Now let's talk about the next triangle, a 24 and 25. Okay? Still y and r, alright? Big number is always r. It's always positive. Here's beta. This is not drawn to scale, guys, so bear with me. R is 25. My y, okay, is 24. All right. And then my x. Guys, to be honest, again, this is for beta. I'm going to have to use my calculator. You can do Pythagorean theorem if you forgot this. You could say c squared, this is b squared, this is a squared, something like that. I'm going to check that actually using this. Alright, 25 squared, I believe it's 7, but let's see if I'm right. Probably, knowing me, I'm going to be wrong. It's a Monday, actually, so, give me some slack here. 25 squared minus b squared. Yep. Square root of 49. Of course, why did I even check? It's 7, so I was right. Okay. You have calculators on your phones. You can download an app that's a calculator. You'll be fine. Okay? So, cosine though. What is cosine? Remind yourself, cosine, all my colors over here, of alpha is equal to, that is, cosine is equal to x over r. Therefore, 4 over 5. That's what this value is. Some of you are like, Mr. Graves, I think you made a mistake. I almost did. Yes, in a triangle, this would be a 7, 24, 25 triangle. But we put this on a coordinate plane. And we dissected each leg and hypotenuse, all right, in terms of x, y, and r. This is in the positive y direction. It's supposed to be y. This is r. It's always positive. This is a negative x direction. So actually, x is equal to negative 7. So cosine of beta is equal to negative 7 over 24. We'll plug that in right here. Okay. Negative 7 over 24. Ah, 25. What am I doing? I'm so sorry. Told you it's a Monday. X over R. R is 25. Life goes on, I make mistakes, you know me. Nothing new in class, right? Alright. Minus. I'm going to tack back on this stuff. 3 over 5, we already knew that because we were given that. And then we were also given 24 over 25. So what are we getting here? Well, lucky for us, we're going to have a common denominator, right? Because both 5 times 25. But what about up here? What's 4 times negative 7? That's a negative what? 28. 3 times 24, right? It's going to be 72. And then 5 times 25. Well, think about this. This is how I always think about if I'm multiplying 25 times something. Well, 4 times 25, 4 quarters gives me $1, right? Well, here we have 5 quarters, that's $1.25 or 125 cents. Alright, now this looks weird. Negative 28 minus 72. Alright, you're going to add them. Kind of like a keep change situation, right? So what do we get here? That's going to be 10, rounds up. I believe that is 100. A negative 100 over 125. How about that? They both have a common factor of 25, I believe. So that would be a negative 4 over 5. That is what that equals. Alright? So, cosine of alpha plus beta, its numeric value, given these parameters and situations, is negative 4 over 5. Now what I want you to do, I want you to try still number 23, but on the previous part, sine of alpha plus beta. Do the same thing. Right? You're going to have to use a different identity to expand, but guess what? You're going to use this exact same, because it's the same problem, you're going to use this exact same setup here with these triangles. You already have the values for cosine of B, cosine of A. Just use them, but obviously with a different identity, got to change. Alright? This is where it's going to get a lot of people. Alright? I'll give you more practice problems. I guarantee you that in the following week. Alright, so that's it. Please guys, finish this packet. You can do this. You know where to find me. I'm going to be on Remind. You can message me anytime. I'll be there for you. I'll even help you out. Send me a picture. Hey, where did I go wrong? I will send you a picture of what you did wrong and I will fix it and we can go from there, okay? Guys, this is a time we're still in school. You got this. Don't use this as an excuse. We're people, as human beings, we're past making excuses. We overcome adversity. Right now we're in a time of adversity, but you still got to learn. You still got stuff to do. I am here to help you. You got to make the effort to do what you need to do, what you got to get done. I'm here for you. You know that. I'm not giving you packets and just saying, hey, go for it. I don't care about the rest of the year. No. If this is going to be permanent, I want to make sure I'm giving you the best education I can through whatever medium, whatever resources I can give you. But you got to take the initiative to get it done. I'm here for you. Let's get this going.